Hello students, let us discuss formal charge in the chapter Chemical Bonding and Molecular Structure. As we have learned that the polyatomic ions have some charges, that is a net charge is possessed by the ion as a whole, not by a particular atom. So, formal charge gives the number of electrons which each atom owns. Let us define formal charge. The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in the Lewis structure. Definitely, you will find difficulty in this definition. Let us talk with an example. Ozone molecule. Ozone, the formula is O3. In this molecule, there is no net charge. So, we'll be writing O3 as it is. That means here there is no net charge. That means the net charge is 0. But ozone molecule is made up of 3 oxygen, and when you look at the structure in this, each atom possesses some own charge. Like here there is one positive charge, here there is one negative charge, and here there is no charge. So what we can say that this positive charge is the formal charge for this oxygen, this negative charge is the formal charge for this oxygen, and here there is no formal charge. That means the formal charge gives the number of electrons which each atom owns. That means it gives the charge on the particular atom which is present in the ion. That all together gives the net charge. When you find out the net charge, as I told you, for ozone it is 0. Why it is 0? Because here there is plus 1 charge, so plus 1, and here there is minus 1 charge, and here there is no charge, so I can write keep 0. So that is equal to plus 1 minus 1 cancel 0. So what is the net charge of this ozone molecule? The net charge is, we can keep, there is no net charge. So this is actually the 0 which we got here, that is the overall charge of ozone molecule, that is 0, but the formal charge for each oxygen which is shown here. So that is the formal charge. So how we find out the formal charge? We have a formula here, that is formula charge. In short, I am writing Fc of an atom in the Lewis structure is equal to, that is the total number of valence electrons in the free state, that is the valence electron, not in the combined state, in the free state, that particular atom, that is a valence electron, minus total number of non-bonding electron. Non-bonding electron means the electron which is not taking part in bonding, that is a lone pair electrons, minus half of total number of bonding electrons, or we can say the shared electrons. So let us short this formula. We can short up this formula like this. Fc is equal to VE. VE is the valence electron minus total number of non-bonding electron, that is lone pair. So I am writing lone pair in short, LP dot E, that is lone pair electron. Valence electron I am writing in VE minus half of BP electron, that is bonding electron. So let us use this formula and find out the formal charge for ozone molecule. First of all, in order to find out the formal charge for each atom in a molecule, we need to make the Lewis structure. So make the Lewis structure by using the method which we have already discussed. So this is the correct structure for Lewis, that is the Lewis structure for ozone molecule. Here each and every dot plays a very important role. Once you get mistaken in making the Lewis structure, you will be getting the formal charge mistaken. So you need to make the Lewis structure first correctly. Since in this molecule there are 3 oxygen atoms, so first let us number this oxygen atom like 1, 2, 3. So we can say the first oxygen atom, this, second oxygen atom, third oxygen atom in this molecule. We'll be using this formula Fc is equal to Ve minus Lp electron, that is valence pair electron minus half of bonding electrons, or we can say shared pair electrons. Let us do for first oxygen. The central oxygen atom is marked as 1 here. That is, you can see the central oxygen atom is here. This is the first oxygen atom. Let we mark this oxygen atom as 1. Now look at this oxygen atom. We know that the oxygen atom in the free state, that is, it belongs to 16 group. So the valence electron for oxygen is 6. So what is the formula here? Ve, Fc is equal to Ve, that is valence electron is equal to 6 for oxygen atom, minus Lp electron, lone pair electron. Look at the structure here, how many dots are there? This dot is representing a lone pair. It is a lone pair, but lone pair electron means a pair is made up of 2 electrons. So in simple words, just count the dots here. So how many dots are here? That is here 1, 2. 2 dots are there. So that is lone pair electron is equal to 2 here. So that is 6 minus 2 here. Next, minus half. So I am keeping minus half. Bond pair electron. How you find out bond pair electron? So look at, we are finding out for this oxygen atom. Look at on the either side of this oxygen atom, how many bonds are there? How many bonds means the number of lines, count it. So here 1, 2 and here 3. 3 lines are there. That means 3 bonds are there. And 1 bond means 2 electron. So when you count in this way, this line, here 1 electron, here 1 electron. So that is 2 plus 2, 4, 5, 6. 6 electrons are the bonding electrons. So bonding electron is equal to 6. Got it? How you find out this bonding electron? First of all, surrounding to this oxygen atom, find out how many bonds are there. So total 1, 2, 3 bonds are there. 3 bond means, we know that 1 bond made up of 2 electrons. So multiply with 2. So that will give rise to 6 electron. That is the bonding electron. So we got that 6 electron. When you solve this one, that is 6 minus 2 minus half into 6 equal to plus 1. So that is plus 1 is the formal charge on this oxygen atom. That is the first oxygen atom. The formal charge is plus 1. Now let us do for the second oxygen atom. That is, we have marked here second oxygen atom. The end oxygen atom which is marked as second, that is, we are talking about this oxygen atom. Look at this oxygen atom. What is the valence electron? Valence electron is same for all the oxygen atom because oxygen atom belong to 16 group in the modern periodic table. So the valence electron is 6. So 6 is the valence electron. So we are writing 6 here. Minus Lp electron, lone pair electron. Here 2 lone pairs are there. Here 2 lone pairs are there. That is this lone pair and this lone pair. One pair have 2 electrons. So total how many electrons are there? In simple words, I told you to count the dots around the second oxygen atom. How many dots are there? That is 1, 2, 3, 4. So total 4 dots are there. So that is the valence electron which we have already wrote here. Lp electron, that is lone pair electron, is 4. Next, minus half. What is the bond pair electron? Look at this atom. how many number of bonds are surrounding to this? That is, only 2 bonds are there. So 2 bond means that is 2 into 2. So that is equal to 4. So one bond having 2 electron. So 2 bond means 2 into 2, that is equal to 4. So that is we are getting the bonding electron equal to 4 here. So when you solve this one, we'll be getting 0. So that means what is the formal charge on this oxygen atom? That is 0. That is the formal charge for this oxygen atom is 0. In the same way, we'll be doing for the third oxygen atom. That is a end oxygen atom marked as 3 here. That is, we are talking about this oxygen atom. Now look at here. In the Lewis structure, here, this oxygen atom, here the valence electron same, that is 6 because it belongs to 16 group. So 16 minus 10, that is equal to 6. What is the lone pair electron here? Count the dots here. When you count it here, that is 1, 2, 3, 4, 5, 6. 6 dots are there. So lone pair electron is equal to 6. What about the case of bond pair electron? Bond pair electron, because here there is only single bond. So we can say that only 2 electrons are there. One bond, that means one bond into 2. That is equal to 2 electrons. So that is we are getting here 2. So when you solve this one, we'll be getting minus 1. So what is the formal charge on this? That is minus 1. So we come up with a formal charge for each oxygen atom. So let us write the formal charge for each oxygen atom. It will be in this way. So hence we can represent the ozone along with the formal charge as follow. So we have find it out for the central atom, that is plus 1. For this the formal charge is 0, and for this oxygen the formal charge is minus 1. So what will be the overall charge or the net charge? That is the net charge, the charge on each atom, that is for this it is 0, for this it is plus 1, and for this it is minus 1. So when you solve it, that is equal to 0. So we can say that the overall charge net is 0. So we will not keeping any net charge on this. It shows that the net charge is 0 here. So this is all about the formal charge which we have discussed for the example ozone. So you have to try another example in order to get this concept more clear. Have a nice day.